Video coverage of M2M Evolution Conference and Expo is brought to you by Content Boost, the content marketing specialists. Amplify your sales today.
Good afternoon. My name is Rich Blumseth. I'm a product management director with Echelon Corporation. I know I'm the last person between you and the cocktail hour, so I'll try to make this quick. Well, maybe quick if the PC works. That's unusual. All right, so a brief introduction to Echelon, a little bit what we see as the vision for the Industrial Internet of Things. I'll describe our platform for the Industrial Internet of Things, talk a little bit about how to develop applications for the platform, some commercial applications, and a use case. Worked that time. So Echelon's a control networking pioneer. We've been enabling M2M applications since 1988. We're used in a variety of applications, including building controls, lighting controls, smart grid automation. A few example key customers, for example, are RNL, who has 30 million Echelon-enabled meters within the country of Italy. Recently, Siemens announced they had shipped 1 million room controllers based on Echelon technology, and other key customers like Honeywell and Philips, Vattenfall throughout the world. But we do see the Industrial Internet of Things as the next big opportunity for this technology and this platform. So our vision, though, is that for the Industrial Internet of Things to happen, first of all, we need the Industrial Internet. And the Industrial Internet is a term coined by GE to sort of differentiate industrial uses of the Internet versus the consumer Internet. Because the industrial applications have more stringent requirements, have to do more analytics, have to do more operations. And a key part of the Industrial Internet is big data, as we've heard earlier. But there is no big data without the small data that drives the big data. So the small data comes from those devices and assets at the edge of the Industrial Internet. And it's those devices at the edge that we concentrate our efforts in our platform. But a unique thing about our platform is not only that we can get the data from those devices at the edge into the cloud, but also that we can enable communications between the devices, to let the devices talk autonomously with each other and control each other, so that you can have tighter control loops, more reliable operation, even in the face of communication failures. So with that vision, we developed the IZOP platform, which is our platform for the Industrial Internet of Things. The platform does three things. First, it enables communities of devices. So these are devices that can communicate directly with each other on either wired or wireless media. Then we have routers that connect those communities to applications and to cloud services. And finally, we have cloud services and network management tools and network installation tools. So we enable that platform through sets of products. First set of products are chips, stacks, and modules that go into those devices at the edge, whether they're wired devices or wireless devices. We have chips, stacks, and modules that go into those devices to make it faster to develop these communicating devices. We then have routers that connect these networks that are all IP enabled into the cloud, again through IP connections. And finally, management software for doing management of large applications or installation of large networks. So the first of those, the device stacks. The device stacks are kind of the core. The device stacks are what enable these communities of devices to communicate with each other. We have three device stacks, a large EX stack, a mid-sized DX stack, and a highly optimized small AX stack. The large EX stack is available as a free download from iiot.echelon.com. Developers can create applications for the devices using Python or C++ or C. We include all the source code for free. And we include reference implementations that run on a Raspberry Pi, a $35 Linux computer, or BeagleBone Black, a $45 Linux computer. Or you can port to the processor of your choice, since you have full source code for the stack. We include sample source code for example applications and schematics for those applications that work with the Raspberry Pi. The DX is just a slightly smaller stack for more memory-constrained processors. And then we have a version of the stack that we've ported to our FT6050 chip. The FT6050 is a complete system on a chip, so it includes that complete device stack on the chip, includes 4 processor cores, includes memory, includes I/O, and a hardware UART. We've implemented control services within the stack, so all these devices communicate with data points. There's up to 200 bytes per data point. We have unicast and multicast addressing, so that one device can talk with another device or with up to 32,000 other devices. And we support reliable message delivery between the devices using acknowledged services or request response services. The programming model is very simple. To write a Python application to send a piece of data, 1 line of code. To write a Python application to receive a piece of data, 3 lines of code. We can create web pages, so we have a free service stack as well. The service stack provides a REST API that provides an interface into the network for web pages or web applications. So with 1 line of code, this is REST code, I can get all the devices in the network, or with 1 other line, I can get all the temperature data points in the network and all their values. We include an example application with the stack, with example devices that show a simple lighting system. The lighting system has environmental sensors that measure temperature, humidity, occupancy, and light level, a touch keypad that allows you to control the lights from a little 2.5-inch screen, touchscreen display, and an LED controller that controls 2 3-watt RGB LEDs. We include example web pages that are all written in HTML5 and JavaScript that show you how you can create nice graphical interfaces to view the devices in a network and to control those devices in a network. Whoops, hold on. Why isn't this sound coming out?
There's a plug up there with the audio jack in your computer hanging somewhere.
Plug. Right there.
This router connects the lights that are talking at the IZOP platform and access.
Okay, let's see if
How
this works.
manufacturers can use it to create their devices for the industrial Internet of Things. I have devices here from 3 manufacturers. Center, I've got the devices included with Echelon IZOP software development equipment. These devices create a simple lighting system where I can push buttons on a keypad.
I can hear a little bit.
Control the color and
Are you in the right
lights.
port? Is
Now
this the
these
earplug
lights
port?
are also connected
Should be.
through Echelon.
I can't see. It's the earplug. But where's your speaker?
Wi-Fi to a simple free topology twisted pair network. This free topology twisted pair is running over here. I'll tell you what, I'll just talk through it. So the reason for this. So this is the demo. We don't want to bring a whole demo here because that'd be a lot to carry. So this is a demo running in the IZOT lab back at Echelon. So I'll just explain it as I explain it. I know. It's my twin brother. So what we have here are 3 panels with devices from 3 manufacturers showing kind of a first use case of applying this technology. The center contains devices from Echelon, which are the example devices I talked about. And so it's a simple lighting system. You see I can push buttons on a keypad and control the lights from that keypad. You see the router that's routing between this panel and the other panels. And so that's a complete lighting system. Now that lighting system is communicating with the other panels on a simple twisted pair wire. So we call that free topology twisted pair. Much easier to wire than Ethernet. We can do Ethernet, but we can also do twisted pair. So we have devices from iNet Supervisor over here. This is one of the first devices created based on our new chip. So that's their building controller. So that's something that would go into a room of a building to control the devices within a room. And they also have a router that's routing off to BACnet, which is another protocol used within commercial buildings. The right-hand panel is from Smart Controls. Smart Controls is another vendor of products for building automation. They've created a new controller based on our chip. That's their controller there. So you can see that same twisted pair of wires, then it's going between the three panels and allowing all these devices to communicate directly with each other without any server or without any separate controller. We then have these networks tied into two workstations. This first workstation is running the installation software that can be used to install the devices to talk with each other. So that software represents the devices, that's the green boxes at the bottom, and represents the blocks on those devices, that's the blue on the top. And you see the lines between them. That's all the connections between the devices that allows those devices to communicate with each other. And then finally, we have a commercial workstation. This is some software from Iconics that's running, that's also monitoring those same devices. And it's using a different protocol. It's using BACnet IP to communicate with all these devices. And by using a standard protocol over this FT media, we have a very low-cost way of installing devices and still use standard commercial software since it is standard BACnet IP. So, and one very brief use case, got a few seconds. Interesting use case of our technology that's already in operation that you can all go see next time you're in Vegas is the Bellagio fountain. That's a fountain with 27 million gallons of water and uses 7 megawatts per show. And it's monitored by our technology, and it monitors the pumps and the lights. And the Bellagio Hotel tells us if this system fails, it costs them millions of dollars per day. So reliability for them is the most important aspect, and they get that from our technology. So my last slide, what I've shown is no compromise control, industrial strength reliability, a technology that gives you a choice of IP links and protocols with very low implementation and installation cost, all available from iot.echelon.com. Thank you.
Video coverage of M2M Evolution Conference and Expo is brought to you by Content Boost, the content marketing specialists. Amplify your sales today.